Hello geometry students, this is Mr. Fugay, and in this video we are going to talk about how to evaluate trig ratios in our calculators, and then we will begin to introduce how to solve trig equations in our calculator. Alright, so the first thing you need to do is have a calculator for this video. I will be showing this using the TI-84 Plus on the right side of the screen. However, you can use the TI-30 calculator, which is available online as well, or use your own personal calculator. It will all take care of itself. Even technically a phone calculator works, although not ideal. Okay, so the first part of this lesson, we are going to evaluate trig ratios. So unlike what we've been doing using the unit circle and the trig toolbox, we can actually find any ratio that we want using our calculator. The biggest thing to note here is to know how to change modes between degrees and radians. So if you press the mode button on your calculator, you will see hopefully an area where you can change this. Right here is where it's on mine. So currently it's in degree mode, which is what I'm going to be using here. Okay, so the first one we're going to be doing is sine of 217.4. And so when I evaluate that, it is as simple as just getting that answer. That's it. That's all we're doing. Now there are going to be some additional caveats that I need to show you here, but this is 0.607. It wants me to round to 3 decimal places most likely. There it is, says it right there. So this is going to be what my ratio is. Now you will notice for the next one, it is not written with degrees. So that means if there are no degrees listed, we are going to want to switch it over to radian mode. Typically a radian is going to have some sort of pi value in it. So this would be tangent. And then we're going to enter fraction 15 pi over 17. And when I evaluate that, by the way, I don't have to close that parenthesis just because I'm done my calculations. It's probably good practice too. But it's going to be negative 0.387 that I get as my answer. Now I want to note on this next one, a lot of students will think that this is degrees. But because there is no units, if you notice there are no units provided, if there are no units, it is always going to be a radian that you're evaluating. Degrees must show the degree symbol. So you'll see down here in letters D and F, we will be back in degree mode for those questions. But for letters C and E, we're going to do this in radians. So cosine of 5.91, again, making sure that we're still in our radian mode, is going to be 0.931. Now, let's talk about actually letter E first, because we're going to stay in radian mode to answer this one. But you'll notice that this is asking secant, and most calculators do not have a cosecant, secant, or cotangent button. So what do we do in that situation? Well, we're going to use the reciprocal property that secant provides us, and that is that the secant of theta is always going to be equal to 1 over the cosine of theta. So since I know what my theta is in this case, right, it's 4.45, I can rewrite this in my calculator as 1 over cosine of 4.45. Notice that I'm not flipping the angle. I'm not flipping the angle because I'm taking the reciprocal of the ratio, not the angle. That's why in my calculator I will then insert a fraction, 1 over cosine of 4.45. Now, if your calculator does not have a fraction button, you can also just do it as simple as 1 divided by cosine of 4.45. And you'll see that no matter which way that I ended up doing it, I got the same answer here. So for this problem, it's negative 3.855 here. So that's going to be my ratio. All right, 2 more for this first part of the lesson. We have cosecant. Now we're back in degree mode for these last 2, so let's go ahead and switch my calculator back to degree mode. Done. All right, and so for this one, just like the last one, we have to figure out what the reciprocal of cosecant is, which we know is going to be sine. So the cosecant of theta is equal to 1 over the sine of theta, and so what I will be evaluating in my calculator instead here is 1 over the sine of negative 34.88 degrees. Again, ensure that you are back in degree mode because that will make a difference. So this will be 1 over sine of negative 34.88. And when I evaluate that, I get negative 1.74, and then we'll round that up to 9 in this case. And then for the last one, we're going to go ahead over to letter F. And one other thing I should note here, and I guess I'll mention it on this one too, the fact that this is a negative angle, we do not no need to find a coterminal. So if you remember when we were doing the unit circle in the trig toolbox, we were going, oh, if the angle is negative or if the angle is really big, we would end up adding or subtracting 360 to be able to find its coterminal angle between 0 and 360. Well, we don't need to do that here because the calculator will already take that into account. So moving over to the last one, this is another reciprocal. And so here's the last one you need to know. Cotangent is equivalent to 1 over the tangent of theta. And so in my calculator, what I will be typing is 1 over tangent of 648. Again, do not take the tangent of, some people will write this, and I'm going to just note this. You don't write this, right? You would not do this. And the reason why is essentially that is almost basically saying what is the tangent of 0. Like it's not actually evaluating what we're looking for. You do not take the reciprocal of the angle, you take the reciprocal of the ratio, which is the result of taking tangent of that angle. So 1 over tangent of 648. And that answer will give us negative 0.325. Final answer. So that's how you evaluate the ratios here. Now, in the second part of the lesson, we're going to talk about how we're going to work backwards. So here's a quick geometry rewind. Back in Unit 5, we learned the concept of solving a trig equation for theta. So if we take a problem here like sine of theta equals 6 over 13. And what we learned is we learned this new idea called the inverse ratio. There's sine inverse, there's cosine inverse, and there's tangent inverse. And so in that situation, we would take the sine inverse of that ratio. So you'll see that we rewrote it, and then in my calculator, we evaluated it in degree mode and got an answer of 27.486, blah, blah, blah. Rounded the answer, and we got 27.5. Now, none of that's really going to change here in this new unit. What we do have to consider, though, is that we were only always looking at the quadrant 1 answer. We were only looking at angles between 0 and 90. And now we know that there can be answers in other quadrants. So because the sine ratio is positive here, we know that there will be, that's supposed to be the word positive, that we know there's going to be an answer in quadrant 1, which we found, but also quadrant 2. And so down here, the last part of this review is telling me that since I've acknowledged that, this 27.5 is my quadrant 1 answer, but this is also simultaneously going to be my reference angle. And that reference angle is going to allow me to go find my quadrant 2 answer by doing 180 minus 27.5. And if you were to go ahead and actually put sine of 27.5 in your calculator and then sine of 152.5, you will see that you get the exact same ratio both times. So let's see how we can put this into action. So looking at the next page here, when solving, you want to drop the negative sign when evaluating the trig inverse expression. The reason why we do this, so I'm going to highlight this, the reason we drop the negative sign when we're evaluating an inverse trig expression is this will always give me the quadrant 1 answer, but more importantly, it gives you the reference angle. And that's what we're going to look at for these final examples in this video. So looking at the very first problem here, first thing I'm going to acknowledge is the fact that this is a positive ratio. And because it's positive, we know that cosine is positive in quadrant 1 and quadrant 4. And so what we're then going to go ahead and do is take the inverse cosine of 0.786. Now it was already positive, so I didn't have to do anything with this. And I get 38.2 degrees. That, remember, is going to be my quadrant 1 answer, but it is also going to be my reference angle. And so when I write down my final answer, 38.2 will indeed be my first answer. My second answer, since it's in quadrant 4, we've learned that you do 360 minus the reference angle, and that's going to give me my other answer here, which is 321.8 degrees. And that's it. There's your process. There is the extra step that we have to do. Now, let's move on and let's talk about what happens when it's negative. Because in this situation, we see the negative sign, and we know that sine is negative in quadrant 3 and quadrant 4. But here's what I'm going to recommend. When I take the inverse sign in my calculator of 0.499, and I should probably show you on the calculator here. So second sign, I'm using the positive value. So I'll go ahead and we'll note that here. So we dropped the negative sign, And the reason we're dropping the negative sign is to get the reference angle. It's a strategic move to allow us to always have our reference angle no matter what. This is 29.9 degrees. The significance of this is that this is my reference angle. So now I can find my quadrant 3 answer. To get my quadrant 3 answer is going to be 180 plus 29.9. And that's going to give me, 209.9 degrees. And then to get my quadrant 4, just like the last problem, we're going to do 360 minus 29.9. And that's going to give me my second answer, which is 330.1 degrees. So drop that negative sign when you're taking the inverse ratio. Now, the final thing we have to talk about in this video is what to do when you have a reciprocal ratio, like cotangent. So just as a reminder here, that cotangent is the reciprocal of tangent. So what I want to do is write a tangent equation instead. And I know that tangent is 1 over the cotangent of theta. Well, guess what? I know the cotangent of theta is equal to negative 1.66, which is what I'm going to write here. So my tangent equation that I'm going to use will be tangent of theta equals 1 over, and since I know what the ratio is, I'm going to write that ratio in my denominator, okay? Now, from this point, once we've rewritten it, now we proceed like normal. Tangent is negative in this case, so tangent is negative, we know, in quadrants 2 and 4. So I'm going to take the inverse tangent of, now you can leave this as 1 over negative 1 point, actually not the negative. Remember we said we dropped the negative sign? 1 over 1.66. Remember, that ensures you by dropping the negative sign that you will get the reference angle. And that will always just be a uniform way of being able to solve these. And so I get an answer of, let's X that out, 31.1 degrees. And I'll just continue to reiterate, that is our reference angle. That is not our answer to our question. To get our quadrant 2 answer, we're going to do 180 minus 31.1, and that's going to be 148.9 degrees. And then my quadrant 4, as we've seen in the last two problems, is 360 minus 31.1. That gives me 328.9 degrees. And that brings us to our final question. Now, you should have all the tools to be able to answer this final question for Part D. Feel free to pause the video if you'd like, but I'm going to go ahead and proceed ahead, recognizing that cosecant is the reciprocal of sine. So I know that the sine of theta is equal to 1 over the cosecant of theta, and just like the last problem, we know what cosecant of theta is. So that's what exactly I'm going to write down here. Sine of theta equals 1 over, and then we're going to go ahead and fill in that ratio. Now, we're going to proceed by solving this like normal. This is a negative ratio. We know sine is negative in quadrants 3 and 4, so that's what I'm going to figure out when I take my inverse sine. 1 over positive 1.899. So once again, for the last time, we're going to go second sine, 1 divided by 1.899. And when I do that, we're going to get a reference angle of, actually really close to the last one, 31.8 degrees. That's just a coincidence. That is not our answer. It is our reference angle. But we are going to go ahead and get our quadrant 3 answer by doing 180 plus 31.8. That's going to give me 211.8 degrees. And then finally in quadrant 4, 360 minus 31.8, which gives me an answer of 328.2 degrees. That should be a 2, not whatever that showed up as. And that's our final answer. And that will conclude solving equations. Now, the next video, we're going to talk about what happens when there's some algebraic techniques that we have to do first. But ultimately, remember, when the trig ratio is equal to a number, we want to use the inverse, and we want to use the positive so that we can find our reference angle, so that we can find our two possible answers. That's it. Time to practice. Have a great day.